Hello and welcome. I'm so glad you're here. Have you ever been doing math and all of a sudden letters start showing up, like X and Y? Yeah, it can look a little weird, I know. But today we're going to figure out exactly why they're there. I'm going to break it all down step by step, and I promise by the end of this, it's all going to make sense.
So, let's start with the big question. Why on earth are there letters in math? It's a really good question. I mean, math is about numbers, right? So seeing an A or an X can feel, well, confusing. But here's a little secret. Those letters are actually there to help us. They make math more powerful and a lot easier in the long run. Let's find out how.
All right, here's our game plan for today. We're going to take it nice and easy, one step at a time. First, we'll talk about why we even use letters. Then, we'll learn the cool, shorter way to write math with letters. After that, we'll get to plug in some real numbers and find answers. We'll also learn the official names for all the different parts. Then, my favorite part, we'll learn how to tidy up long math sentences to make them short and sweet. And finally, you'll get a chance to try it yourself. Ready? Let's jump in.
Okay, so first things first, why use a letter? Well, think of a letter like X as just an empty box. Seriously, it's just a placeholder. It's a spot where a number is going to go, but we just don't know which number yet. The number might change depending on the problem. So the letter just sits there holding the spot for us. It's how we can write rules and patterns in math that work for any number.
Now let's get into how we actually write things in algebra. Algebra has a few special rules, and they're all designed to do one thing: make our lives easier. They help us write math in a really short, clean, and simple way. We're going to go over to the three biggest rules today.
Here's rule number one, and it's a big one. In algebra, we like to hide the multiplication sign. It just cleans things up. So instead of writing x times 4, we just squish them together and write 4x. And here's the other part of the rule. The number always goes in front of the letter. Always. So when you see a number right next to a letter, you just know it means multiply.
Okay, here's a special little shortcut that pops up all the time. What about when we multiply by -1? Well, mathematicians like to be efficient, so we make it super simple. We don't write out a times -1, we just write -a. The 1 is kind of invisible. It's hidden, but we know it's there. It's a really handy shortcut to remember.
And our third rule is all about division. Instead of using that classic division symbol, we write it just like a fraction. So a divided by 3 becomes a over 3. The first item always goes on top, in the numerator, and the second item goes on the bottom, in the denominator. Easy, right? It's much cleaner this way.
Awesome. So now we know the rules for writing these things, but what can we actually do with them? Well, this is where the fun starts. We can figure out what these expressions are actually worth, and we do that by swapping out the letter for a real number.
This process of swapping has a special name. It's called substitution. I know, it sounds like a big, fancy word, but all it means is to put in place of. We're literally putting a number in place of the letter. That's it, nothing more to it.
Let's walk through one together. Our problem is 4x plus 13, and the instructions tell us that x is equal to -5. So our job is to substitute -5 everywhere we see an x. Now listen close, because this is a super important tip. Whenever you substitute a negative number, you should always put it in parentheses. So we write 4 times -5 plus 13. First, we do the multiplication. 4 times -5 gives us -20. Now our problem is just -20 plus 13, and that gives us our final answer, -7. See? Not so bad.
All right, now it's your turn to try. What's the value of a squared minus 2 when a is equal to 3? Go ahead and pause here and give it a shot. Okay, you ready? Let's check it. That little 2 up top means squared, which just means you multiply the number by itself. So a squared is the same as a times a. We substitute 3 in for a, so we get 3 squared minus 2. That's 3 times 3 minus 2. Well, 3 times 3 is 9, and 9 minus 2 is 7. Hey, you did it! Awesome work!
You're doing great. So now that we know how to use these expressions, let's learn the names for their different parts. It's kind of like learning grammar for a new language. Once you know the words, it's so much easier to talk about the math and know what's going on.
We're going to use this expression right here as our example. 6x plus 40. Let's take it apart and see what's inside.
First up, we have terms. Terms are just the different chunks of the expression that are being added or subtracted. Think of them as the building blocks. So, in 6x plus 40, we've got two terms. The 6x is one term, and the 40 is the second term. Simple as that.
Next, we have the coefficient. That word sounds way more complicated than it is. The coefficient is simply the number that's attached to the letter. It's the number being multiplied. So in our term 6x, what number is being multiplied by x? It's 6. So our coefficient is 6.
And last but not least, we have the constant term. This one's the easiest of all. It's the term that's just a plain old number with no letter buddy. In our expression, the constant term is 40. We call it constant because its value never changes. It's constantly 40.
Okay, now we're moving on to a really, really useful skill. Sometimes math expressions can get super long and messy. We can actually make them shorter and simpler by cleaning them up. This is called combining like terms. Let's see how it works.
So what in the world are like terms? Well, like terms are terms that have the exact same letter part. Think about it like fruit. If you have 3 apples and you get 2 more apples, you can combine them to get 5 apples, right? But if you have 3 apples and 2 bananas, you can't combine them. You just have apples and bananas. It's the same in algebra. Terms with the same letter belong to the same family and can be combined.
Let's look at a few examples to make this crystal clear. 4a and negative a? Yes, they're like terms because they both have the letter a. What about 10 and negative 8? Yep, those are like terms too. They're both constants. Now look at the other side. 4a and 5b are not like terms. One has an a, one has a b. Different families. And 3x and 10 are not like terms. One has an x and the other is just a number. No match.
So how do we actually use this? Let's simplify this expression. 6x plus 3 minus 2x plus 7. First step is to find the families. I see 6x and a negative 2x. They're in the x family. Then I see a plus 3 and a plus 7. They're in the constant family. Now, we just put the families together. So what's 6x minus 2x? That's 4x. And what's 3 plus 7? That's 10. So our new simplified expression is just 4x plus 10. Look how much cleaner that is.
All right, you have learned so many new things today. Now it's time to put all those skills together for one last practice problem. You've totally got this.
Okay, here it is. Let's simplify 2a minus 4 plus 3a plus 1. Go ahead and pause and see what you can do. How'd it go? Let's solve it. Because there's a plus sign between the parentheses, we can just drop them. That gives us 2a minus 4 plus 3a plus 1. Now, let's find our like terms. We have 2a and plus 3a in the a family. And we have negative 4 and plus 1 in the constant family. Let's combine them. 2a plus 3a is 5a, and negative 4 plus 1 is negative 3. So our final simplified answer is 5a minus 3. Fantastic job! Let's do a super quick recap of everything we learned today. We learned that those letters in math are just placeholders for numbers. We learned some simple rules to make writing math shorter. We learned how to substitute numbers in for those letters. We learned the names for all the parts, terms, coefficients, and constants. And we learned how to clean up expressions by combining like terms. You have officially learned some of the biggest ideas in algebra today.
Always remember that math is a journey made of lots of small steps. And you know what? You took a really big, important step today. You should be really proud of what you accomplished. Thank you so much for learning with me, and I can't wait to see you for our next lesson.